Right, so for this video, we'll discuss the paper for May-June 2025, Pure Mathematics 1, Paper 1-1. So let's start with question number 1. They want us to solve this equation that involve the sine theta, right? And then the theta must be between negative 180 to positive 180. Okay, to solve this question, we need to get rid of the sine theta as a denominator, right? If not, it is quite hard or tough for us to solve it. So what I'm going to do is that I have to multiply the whole equation by using sine theta. So when I multiply the whole equation by using sine theta, 6 sine theta will become sine square theta, because sine multiplied with sine you get sine square, right? So 6 sine square theta. Then 1 multiplied with sine theta, you have sine theta. Then this fraction, you multiply with sine theta, you're having a 2. Yeah, then after that, if I try to move every terms to the other side, basically I'll be having a quadratic equation in terms of sine theta. I don't know whether you're aware or not, but if let's say for those who are not able to see the pattern, you can just let y equals to sine theta, and eventually you will see that the equation becomes 6y squared minus y minus 2 equals to 0. So I hope that you can see it from this part, alright? Okay, then since we are having a quadratic equation, therefore we are trying to solve it by using the quadratic equation. When we are trying to solve the quadratic equation, how we actually solve them? You can use the quadratic formula if you want. If you don't want, then you can try and see whether this equation can be factorized or not. So if I try out, I realize that this equation can be factorized. Okay, so I'm having 3 times 2. Then I'm having a 2 and 1 here. Then I should have negative 4 plus 3. Yeah. Alright. Okay. Then I'm try to solve it. For this 2 bracket here, I'm having sine theta equals to 2 over 3, and also sine theta equals to negative half. Alright, then after that, we try to solve it by using the quadrant concept. Okay, so for this one, I'm not going to show you the solution in terms of y, because basically they are the same, just that you change the sine theta become the y, so that you see clearer in the quadratic form equation. Alright, okay, then now let's continue from here. I need to solve the 2 equations here. The first one is sine theta equals to 2 over 3. Another one is sine theta equals to negative half. Usually for me, I will prefer to find the basic angle first. So let's find out the basic angle. And the basic angle for this equation is sine inverse 2 over 3. Press calculator to help you a little bit. By right, you should be having 41.8 degrees. Alright, then after that, we need to go through the quadrant to get the final answer. Alright, so I believe all of us here know the quadrant here. In different quadrants, you are having the different trigger, which is positive value, right? In the first quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. Fourth quadrant, cos is positive. Okay, and then when you are trying to get all the answer from different quadrants, there are a formula, right? So according to positive angle, yeah. So let's talk about positive angle. For positive angle, first quadrant, the answer is basically the basic angle. Okay, then for the second quadrant, to get the answer in the second quadrant, for the angle, you should take 180 minus the basic angle. Alright, then I'm not going through for the third and fourth quadrant here, because if I have a look for my range, it is stated between negative 180 to positive 180. I focus on positive angle first. So positive angle means 0 to 180, which is the first 2 quadrant only, right? Therefore, I just write out the solution for first 2 quadrant here for you. Okay, I'm having basic angle 41.8. Right? And then after that, how can I get the theta? So to get the theta, I need to go through the quadrant. For the first quadrant, is tangent, we are looking for sine, then with a positive value right here, right? Sine positive 2 over 3. In the first quadrant, is it sine positive? Yes. So that means I want to answer from this quadrant, it should be 41.8, which is the basic angle. Theta means basic angle, yeah? Okay, after that, we go to the second quadrant. In the second quadrant, is it sine positive? Yes, also. So I want to answer from this part. So to get the answer from this part, you take 180 minus the theta. So you take 180 minus the basic angle, which is the theta. So by right, you will be getting 138.2. Alright, then for this equation, right, I didn't go through the negative angle. to get the answer. Do you know why? Because if I want to go through the negative angle, means that I need to measure it from bottom. That means in the clockwise direction. So when I want to get the answer from this quadrant and this quadrant, right, both quadrant here didn't show that sine is positive because we are looking for sine positive, sin theta positive, right? So sin theta is not positive in third and fourth quadrant. That's the reason why I didn't go through the negative angle for third and fourth quadrant, right? So that means for this particular equation, the solution is these two, 41.8 and also 138.2. Alright, so there's no negative angle, yeah, for this equation. Excuse me. Then let's continue to the sine theta here. Alright, then this is my second equation. So for sine theta equals to negative half. I want to get the basic angle first. So what is the basic angle for this equation? You press calculator, sine inverse positive half. When we are getting the basic angle, we always ignore the negative sign. Alright, so we take sine inverse positive half, and by right you'll get a very nice value, which is 30 degrees. Alright, and now I need to go through the quadrant to see which is the answer that I want to accept for my theta. We are aiming for sine negative. Alright, so for sine negative, you realize that both first and second quadrant, right, for positive angle that we want to consider just now, are having sine positive. Therefore, the sine negative should appear in the third and fourth quadrant. So to get an answer for third and fourth quadrant in our question here, they are asking for negative 180 to positive 180, which negative 180 to 0. That means you need to consider the angle in clockwise direction. Right? So when you are trying to consider an answer in clockwise direction, then you have to start from this quadrant first, followed by this one. For the fourth quadrant, to get the answer from the fourth quadrant, right, the answer is negative basic angle. Then for the third quadrant should be negative 180 minus the basic angle. Okay, right, so let's go through the quadrant again. So we start from this one first. In this quadrant, is it sine negative? Yes, right? So the answer should be negative theta, which is negative 30 degrees. And after that, for tangent, for this quadrant, is sine negative? It is also yes. So you have to take the answer by taking 180 minus the basic angle, then you put the negative in front. So by right, you'll be having negative 150. Alright, so I should stop here because of these two quadrant on top doesn't give me the sign with a negative, sin theta with a negative sign. Alright, so that's the reason some students, they ask, why sometimes I only consider the certain quadrant at the bottom, didn't consider the equation on top. It is because of what kind of sign do we have in the trigo equation, and also we need to look at the range of the theta that they want us to find. Alright, okay, so I will stop here for this second equation here, and we need to if you can, I will try to suggest you try to list out all the final answer at the end of your solution. Alright, so according to what we solve here, we are having the smallest angle is negative 150, followed by negative 30, then 41.8, and also 138.2. Yeah, so basically this is how we solve the question number 1. Question number 2, we are given the equation of a curve for the dy dx. dy dx is equal to this one. And then the curve passed through the point A. Find the gradient of the normal to the curve at point A. Right, so let's start. Before you can find the gradient of the normal, right, let's consider, let's think about what is the equation that is related to maybe the gradient of normal and also the tangent. By right, we should know when we substitute a value inside the x for the dy dx, you will get the gradient of tangent. And normal and tangent are perpendicular to each other, right? So you should know the gradient of normal multiplied with the gradient of tangent should be equals to negative 1. And to continue and get the gradient of normal, we need to find the gradient of tangent first, which is not too hard because we can get the gradient of tangent from the dy dx. Alright, so let's start. I want to get the dy dx for the equation at the point A, because for this question they're asking for point A as well. So for point A, the x coordinate is 4, y coordinate is negative 11 over 2, right? I substitute the 4 into my dy dx equation. Okay, so 4 times 2 is an 8, right? 4 times 2 is 8 minus 5, then power 3. Then minus 9, and then square root of the 4. When you're trying to get the answer for this one, you'll be having 90. And you should know that this is basically the gradient of tangent. And like what I mentioned just now, we are going to use the result where the gradient of normal and also the gradient of tangent multiplied together should be equals to negative 1. And from here, very easily, you can see that the gradient of normal should be equals to negative 1 over 90. So this is what we have for the gradient of the normal. Alright, then let's have a look for part B. Part B, they want to find the equation of the curve. Equation of the curve means the y. Y equals to something something in x. And if you're having dy dx, you want to change it become the y. What's the process that you need to go through? You have to go through the integration. But right, you should know, right, from y going to the dy dx should be differentiation, right? So to do it the other way around, we have to apply integration. Okay? Then let's have a look. How can we start? To get the y, I need to integrate my dy dx. What is the dy dx that I have here? 4, then 2x minus 5 power 3, then minus 9x power half dx. For the integration part, what I do is like, okay, 4 is a constant, I just copy it. I'm having this bracket 2x minus 5 power 3. To integrate this particular term, I copy the bracket power plus 1 become a 4. I have to divide it by the new power 4. Then I differentiate the thing inside the bracket. Differentiate 2x minus 5, I get a 2, right? So I have to divide it by a 2 outside here. Minus 9 is a constant also, I just copy. I focus on the integration for x power half. So x power half, the power you have to plus 1 become 3 over 2. Then divided by a new power 3 over 2. Alright, so we have successfully integrated both terms here. Then don't forget about constant term at the back, which is a plus c, and we need to find the plus c later. Right. Next step, we try to simplify first before we get the value for the c. 4 and 4 can be cancelled off. And I have this half, then 2x minus 5 power 4. Simplify the 9 divided by 3 over 2. You'll be getting 6x power 3 over 2, then plus c. How can I get the value of the c here? You need a point that passes through the equation. And we did given a point, right, which is the a, at 4 and also negative 11 over 2. Just substitute it into the equation that we get for the y. So y equals to half. Then 2x means 2 times 4 minus 5 power 4 minus 6. Then 4 power 3 over 2. Then plus c. Try to simplify this whole equation here without any, if let's say you do it without any careless mistake, yeah, this is what you should get. By right, your c should be, where is it? 2. Okay, then after that, after we get the final answer for the c, then we rewrite our equation again with the value of c found. Okay, so I'm having this equation. Then don't forget about the plus 2 at the end. Okay, you can see that this is the equation of the y that we have, and we can get it by using integration from the dy dx. Right, so this is how we solve question number. We are now at question number 3. The third term of a geometric progression, highlight the keyword geometric progression, is 18, and also the sum of the first 3 terms is 26. they give us two information here. The first one is the third term for geometric equation, geometric progression, and also the sum of the first three terms. It is given that the common ratio is negative, so this is also very important, yeah. Common ratio should be a negative value. Find the 10th term of the progression. Give your answer correct to three significant figure. Right. To solve this question, you have to use the information given on top in the question here to solve it simultaneously. Alright, then let's have a look for a geometric progression, right? What is the general formula for the n term? So the n term will be AR power n minus 1. And then what is the formula for the sum? So the sum of the first n term will be A, then R power n minus 1 divided by R minus 1. Or maybe some reference book, maybe our formula booklet, they are writing it in this way, where 1 minus R power n divided by 1 minus R. Basically, they are the same. Okay, these two formula will give you the same answer basically. Right. This is the formula we have. Then let's have a look how can we apply all this formula to solve the question. The third term of a geometric progression, third term, we are looking for third term which is D3, sorry. D3, if according to this formula here, I'm having AR power n minus 1. A, I don't know what's the value. R, I also don't know what's the value, but I know that n minus 1 should be 3 minus 1, which is equals to 2. Then they tell us that this particular term is having the value of 18, right? So I will let 18 equals to AR power 2. And from here, what I get is A equals to 18 over R power 2. And I will assume that this is my first equation. I'll take this as the first equation here. And I need second equation to get the value for A and also the R, right? Therefore, the second equation is given in the question where they said the sum of the first three terms is 26. Alright, sum for the first three terms. When I want to write the sum of the first three terms, I found that only the first three terms are, so it is not too hard for me to use the basic equation Dn to get the answer. Sum of the first three terms is first term, which is the A, second term, which is A power R, AR power 1, and also the third term is AR power 2. And when you add these three terms together, it should be equals to 26. Alright, then I realized that I know the value for AR squared, which is 18. And I can substitute 18 here, and my equation will become A plus AR equals to 26 minus 18. And the equation that I get here will be A, then 1 plus R equals to 8. I will treat this as the second equation. Okay, and now let us solve the equation here, these two equations here, to get the value for A and also the R. How can I solve them? I will substitute. I solve them simultaneously. I think most of us here should know how to solve it, right? Okay, so I solve the equation number 1 into equation number 2. Okay, A is 18 over R squared. Then multiply with 1 plus R equals to 8. I want to get rid of the R squared, yeah? So I multiply the R squared to the other side, and what I get is something like this. I'll get a quadratic equation in terms of the R squared, and I try to simplify and move everything to one side. I'll be having 4R squared minus 9R minus 9 equals to 0. Then, for this quadratic equation, I can factorize it. I get 4R plus 3 and also R minus 3. Then continue to solve the equation. R equals to negative 3 over 4 and also R equals to 3. And according to this question, right, they did mention that our R value, the common ratio, should be a negative value. That's the reason why I ignore the R equals to 3, which is the positive value. I only accept R equals to negative 3 over 4. Okay, once you successfully get the R equals to 3 over 4, then we can find out the value of the A. To find out the value of the A, you will have A equals to 8 over 1 plus R. And the value of the A is 32. And we successfully solve the equation simultaneously to get the value for A and also the R. Alright, and let's continue for this question because they did not only they want us to find the value for A and R, but we actually want to find the 10th term. The 10th term of the progression, answer into 3 significant figure. Okay, let's continue for one more further step, how to get the T10. So T10 is AR power 9. A is 32. R is negative 3 over 4 power n minus 9, which is n minus 1, which is a 9. Okay, try to press calculator to help you. By right, you'll be getting negative 2.40 as the final answer, 3 significant figure. So I believe that you should understand right what I write here. So you have equation number 1, equation number 2, solve simultaneous equation and get the answer. Okay, so make sure that you find out the T10, yeah, because a lot of students, they will just stop at this part. They forget to find the T10. Alright, so I want to discuss about the solving part for the simultaneous equation. I believe that quite a number of you will ask, for the sum of the first 3 terms, right? Why I didn't use the formula given in the sum? But I just add the 3 terms together to solve. Okay, the main reason is because of, I realized that when I add the 3 terms together, okay, there are not too many terms, there are first 3 terms only. So if I put AR and AR squared equals 26, it is not too long for me to write it out. And the second main reason is because of, I realized that the third term, I already know the value. When I know the value for the third term and I substitute inside, I will make my equation even simpler. That means I have make the r squared, the term with the r squared disappear because I still it with 18, right? Then your equation become comparatively simple, right? So that's the reason why I choose the first 3 terms to solve it. And if we follow most of the students who try out this question, I believe that for the second equation here, they are not using this one, but they use the formula where they are using S3 equals to A, they don't know the value, then 1 minus R power n, which is R power 3, then divided by 1 minus R, 1 minus R. Then if you substitute S3, the value of S3 they give you is 26, right? So if you write 26 equals to this one, okay, then 26, 1 minus R equals to A, then 1 minus R power 3. Okay, so I'm not going to continue, but I will just show you for here. If I try to use the sum formula to make it as the second equation, alright, you will see that the second equation here that I get is comparatively simple compared to this one. Because in this equation, I'm having R power 3. Alright, if I have R power 3, when I substitute A equals to 18 over R squared, if I substitute it here, I will even getting a more complicated equation. But of course, you can still solve it, alright? Because according to marking scheme, they did accept the method here, but they didn't show you how. So when you try to substitute it inside and simplify, you will get eventually a cubic equation, 8R power 3 minus 26R squared, then plus 18 equals to 0. And you get a cubic equation, and you need to show them how you solve this cubic equation to get the answer. To me, comparatively, this method is more complicated because in our AS syllabus, we are focusing on up to the quadratic equation only, right? We still haven't learned how to solve the cubic equation. Of course, you can press calculator to help you and get the answer, right? But to me, I think this is more, it's easier for us to solve it without using any method that you haven't learned before. Alright, so some students will ask how I know that I have to make use of this equation instead of the formula. Alright, for me, usually I would have a look for the equation. I'll have a look for the question first. If I realize that there's something I can directly substitute into the complicated equation, that I will straight away substitute it. Like this one, substitute AR squared by using 18. Basically, you get rid of the term of AR squared, which makes the equation is easier. So I would prefer to choose this method instead of using the formula with higher power, because eventually after you simplify everything, you still need to use the special method to solve for cubic equation. But of course, I understand that there are quite a number of you already know how to solve the cubic equation, but for those who don't know, maybe you need to go back to this basic formula here. Alright, the basic method here, okay, to get the answer correctly. Alright, Okay, so this question is a little bit special. If let's say you use the formula, you'll get the harder equation like what I said. Alright, so maybe you have to think about this method. Okay, right. So this is how we solve the question number 3, right? Oh, we still have part B for question number 3. Let's continue first. Right, so for question number 3, they want you to find out the exact value of the sum to infinity. I forget to write the formula for sum to infinity in the geometric progression. The general formula is a over 1 minus r. Let's recall back again. What is the value of the a that you get just now? It is 32, right? What's the value of the r that you get just now? Negative value 3 over 4. To find the sum of the infinity is very straightforward. A is 32 divided by 1 minus r, which is negative 3 over 4. Very easily, you'll get the answer 128 over 7. Please don't change it become 3 significant figure, because in this question, they mentioned that they want you to have exact value. So you have to keep it in a fraction form like this. Right? Yeah, so this is how we solve the question. Right, so question number 4. We are having a diagram, and then it shows the curve, right? So this is the equation of the curve. And also we're having the line with this equation. The x-coordinate of the point of intersection of the curve and the line are 1 and also 16. So this is the first intersection point, and this is the second intersection point between the line and also the curve. And we should know that this particular value here is a 1, and then this particular value here is a 16. Alright, then now what they want us to find is, they want us to find the area of the shaded region between the curve and also the line. Area of the shaded region. Alright, so let's start. To find out the area below any graph, we have to apply integration. Alright, this question particularly is about integration to get the area. Alright, then to get the area for the certain value, alright, okay, maybe I should mention it like this. To get the shaded area, right, I need to integrate this curve first. When I integrate this whole curve here from 1 until 16, the area that I get is the red color area for this one. But you can see from here, if I want to get only the shaded region, I need to minus the extra equation, which is this triangle here. So can you see that it is a triangle basically? Alright, the green color part is a triangle. In short, to get the shaded area, you should get the area under the graph, okay, minus the area of the triangle. Right, so this is what I plan to do. So first of all, let me start with the area under the curve. So the area under the curve means that the whole red colored part that I tried to shade just now, the red color one, yeah, shaded with red color. So this red color area particularly is attached mainly to the x-axis. So it will be good if you use integration that is related to the dx. Alright. And we need to put in the limit for the x, where the area starts. The area starts at this point where x is the 1. Area at this point where it is equal to 16. What is the equation of the curve? So you're having 5x power 3 over 2 minus 20x. And now I start the integration for this part. So to integrate it, constant is a 5. 5 is a constant, you just copy it. I copy the x, integrate the power, right? So 3 over 2 power plus 1 become 5 over 2 divided by a new power 5 over 2 minus 20x. 20 is a constant, you just copy x power 1 plus 1 become a 2 divided by a new power 2. And after this, you have to substitute in the value 16 and also the 1. For my own habit, I prefer to simplify my equation first or expression first before I substitute in any value. I try to simplify this first part. By right, I'll be having this 2x power 5 over 2. You can see that the expression now looks more simple, right? And for the second term here, I try to simplify as well. So I'm having 10x squared with 16 and also the 1. Now only I try to substitute in the value, the limit for 16. Substitute 16 into the x here, you'll be having 2048. Minus substitute 16 into the 10x squared, you'll be having 2560. Minus substitute the 1 now, substitute the limit 1, you're having a 2. And also for the second term, you're having a 10, so minus 10. And what do we get from simplifying the value here? I will get negative 504. Right? And if you have a look, we are looking for the area under the curve, right? Why do we getting this negative value? It is because of, if you try to observe the diagram here, the area is below the x-axis. Okay, the area is below the x-axis. Therefore, when we integrate the equation, right, we should be getting a negative value because it is below the x-axis. But for the area that I want to find, we assume that everything is positive. Area shouldn't be negative. So we are allowed to directly make it become a positive value, which is 504. This is the area, alright, for the whole part under the curve, or I should say above the curve, right? Okay, so this is 1504. And now I want to find out the area of this particular triangle. When I try to substitute 1 into my curve, sorry, I should say that this is a green color part triangle, yeah? I want to get the area for this triangle so that I can take 504 minus the triangle area to get the shaded area. So how can I find the area of the triangle? I need to know, for me, I want to use the equation half times base times height for the triangle because it is a right angle triangle here. What is the base? Yeah, the base is quite easy because you know that it is value from 16 to 1. This is the base. I want to know what is the height. To know the height, I need to know what is the value for the y when x is equals to 1, right? Okay, so first, I will want to find out the value of y first. When x equals to 1, the equation for the y will be 1 minus 16. So you're having y equals to negative 15. This negative 15 basically means the height. Okay, and now to get the area of triangle, it should be half times base times height. And I know that my half here, my base here is 15, right? Because I'm taking 16 minus 1. And the height here is the value of the y, which is negative 15. But since we are talking about the area, therefore what I'm doing here is I try to make it become a positive value. And I will eventually get 225 over 2. This is the area of the triangle. To get the shaded region, what we need to do? Shaded area. The shaded area part is, you are taking the area under the curve, which is 504, minus the area of the triangle 225 over 2. And eventually, the value that you should get is 783 over 2. Or 391.5. Oh, sorry, 391. If you try to simplify that into the decimal number, this is the value that you should have. Okay, alright, so originally, if you have a look for this question, right, since the whole area is below the curve, therefore, you will be safer if you try to make the area below the curve as positive area first. So as an example, you can see that for this part, area under the graph, the curve, means that, like what I told you just now, right, this is the red color shaded part. To find this red color shaded part, I apply integration, but I will get a negative value because of it is below the x-axis. Therefore, to get the area, I try to change it directly, become a positive value first. After that, only I try to figure out what is the value, the area of the triangle here. According to integration rules and also for the formula, right? If you apply integration, you also get the negative value for your area. So please change it become positive as well. If you don't apply the integration, but you apply the formula for the triangle like what I show you here, then just make sure that you change the value of y, which is the height, as a positive value as well. If not, you'll get a negative value for your area. Okay? After that, only I try to find the shaded area part here. So the shaded area part will be taking the area under the curve, which is the red color one, minus the area of the triangle, which is the green color one, and you will get the shaded area eventually. Right, so this is what we will get. Okay, so just to tell you one common mistake that maybe you might do. This is also what I did wrongly earlier for the first time. Because I want it to be fast, so what I do is that I'm taking the shaded area. I try to apply everything in one step. That means I try to put it as modulus, then I integrate 1 until 16, then 5x power 3 over 2 minus 20x dx, and I minus the area of the triangle, which is half, then base times height. Right, so you can also apply this one in one step where you put the modulus. Modulus means that after you apply everything, you will get a positive, you will get a negative value for the area, and you want to change become positive. All right. So I just want to let you know that if we are trying to do something like what I show you here, you need to be very, very careful, because I did the same, the careless mistake when I use this method, where when you integrate this one, you should be getting a negative value, right? Okay, when you integrate this one, must also have a negative value. Then only you are having a correct answer for negative minus a negative value, which is a positive one. Then after that, only you put the, only you get a correct magnitude. Then after that, only you put the modulus form to change a negative value become the positive. All right. So what I did is, when I want to write out this step, right? This one I still apply it like normal, like what I show you here. But for this one, I accidentally changed the height become a positive value 15. And eventually the final answer for the magnitude of the area is wrong. So if you want to apply this method, please make sure that the value here for this area is still remain negative. This one also remain as negative. Then we take negative minus the negative value, and eventually you take a modulus, only you get a correct magnitude for the final answer area. Alright, if you feel that very confusing, then just try to figure it out part by part. So just like what I told you just now, I found the area under the curve first, make it become positive. After that, only I found the area of the triangle, I make it become positive. Then only I minus curve, the triangle from the curve to get the shaded area. This is the safest way. I feel that it can avoid, or it can help you to avoid the careless mistake. Alright, so if you want to use this, please make sure that you are doing it very, very carefully. Alright, yeah. So this is how we solve the question number 4. Alright, so we are now at question number 5. They want us to find the first 3 terms in ascending power of x in the expansion of each of the following expressions. So there are a few expressions here. And if you have looked for the question, basically it is about the binomial expansion. Alright, then let's have a look. What is the general formula for the binomial expansion here? If let's say I'm having a plus b power n, the first term will be nc0, a power n minus 0, then b power 0. Okay, then for the second term, it will be nc1, a power n minus 1, b power 1. And the third term will be nc2, a power n minus 2, and b power 2. Alright, so if you can't remember the formula here, you can always refer to the formula booklet, the FF19, because it is always provided in FF19. Right? Okay, but this is a general formula that I want to show you here. First term, second term, and also the third term. Because for this question, they are asking for the first 3 terms, right? Okay, then let's continue from here. I'm having 2 minus px power 5. Let's compare it with our question here, the formula here. A will be the 2. B will be the negative px. N will be the 5. First term, nc0. So I'm having 5c0. A power n minus 0. A is a 2. Power n minus 0 means 5 minus 0, you get a 5. Then negative px is the b, power 0. Right? Then second term, 5c1. 2 power 5 minus 1, which is a 4. And then negative px power 1. Then next term, third term is 5c2. A, which is a 2, power 5 minus 2 is a 3. Then negative px power 2. Please make sure that you write out the formula form in the context of the question, where you substitute all the possible, the suitable values, right? And now you just need to use calculator to help it a little bit. If you simplify without any careless mistake by right, it should be 32 minus 80 px and also minus, plus 80p square x squared. Alright, this is the first expansion that we have for the first three terms. So first term, second term, and also third term, and you can see that our answer is in the ascending power of the x. Right, then let's continue further to the second expansion. I'm having this. So again, we are applying the same formula. Alright, so let's start out the first term. First term would be 4. C0, A power 4, B power 0. Second term, 4C1, 1 power 3, then negative half power 1. And also the third term, 4C2, 1 power 2, negative half x power 2. Then again, try to use calculator to help you and simplify it. By right, you'll be getting 1 minus 2x plus 3 over 2x squared. This is what we have for the second expansion. Right, first expansion for the first three terms, second expansion for the first three terms. Basically, it is very straightforward because you just apply the formula. Right, then let's continue to part B. Now, they said given that the coefficient of x squared in this expansion is 93, find the possible values of the constant p. Let's have a look for our question here. In part B, you are having 2 minus px power 5 and also 1 minus half x power 4. And if you try to have a look for 2 minus px power 5, we are having the first three terms here. Then second term, second expansion, 1 minus half x power 4 is this one. Right? Then to simplify this expansion and get the x squared, you have to use the expansion for these two expressions first. For first bracket, your first three terms will be this one. So you just copy down the answer from part 1, A1, alright? We'll be having 32 minus 80px, then plus 80p squared x squared. Multiply with the expansion for the second bracket here, it is 1 minus 2x plus 3 over 2 x squared. Alright, so why the first three term is enough for each of the expression is because of when you try to expand everything, right? The highest power that we get is up to x power 4 already, which means it is more than enough because we are looking for x squared. Alright, so if you try to expand everything, all the x squared is included in our calculation here. Alright, then now, since for this question, they only want us to focus on the coefficient of x squared, so what I do is that I try to focus only on the x squared term. So I take 32, multiply with this one to get something with x squared, right? Yeah, so I take 32, multiply with 3 over 2x squared. When I have 32, multiply with 3 over 2x squared, I will be having 48x squared. Okay, then I try to consider again what kind of expansion will give me something with x squared again. So negative 80px, if I multiply with negative 2x, I will have something with x squared as well. So I multiply both of them together, I will be having 160p then x squared. Then how about the next one? If I take 80p squared x squared, multiply with a 1, I will get something also that is with the x squared. So I'm having 80p squared and also x squared. If you try to expand any other terms, right, they won't give you any x squared anymore. So these are all the possible x squared that I have. And what can I do now is I try to factorize out the x squared and I just keep the coefficient for the x squared here. Alright, in this question, because they told us that the coefficient of x squared is 93. Coefficient means the number in front of the x squared. Yeah? So you can see the number in front of the x squared is this one, this bracket here. I will let 48 plus 160p plus 80p squared. These are the coefficient of the x squared, and it is equal to 93 according to the question. And let's continue further. For this question, they're asking for the values of the constant p, right? So how can we solve this equation now? If you try to rearrange it, and group everything to one side. By right, you will be seeing this quadratic equation in terms of p. Try to simplify further. Then when you get a simple quadratic equation, it is easier for you to factorize it. So I want to have a 32. 4 and 4. 9 times 4 is 36 with 4, right? I want a positive, so positive here, minus. Okay, so I successfully factorize it and I will get the values of the p easily. And for this question, they're asking for the values of the constant p. They didn't say that should we ignore any positive value or negative value. So that means we should accept both answers here. Okay, and these two values will be the final answer for the value of the p. Alright, yeah, so this is how we solve question number 5. Question number 6. We are given equation of a curve like this, and also the equation of a line where the k and p are constants, and now they have given us the value for k and also the p equals 11. Find the coordinates of the intersection point for the curve and also the line. So for this question, we mainly want to find the intersection point. When we want to find the intersection point, we have to solve it simultaneously for the two equations that we have to get the coordinate of the intersection point. Right, so let's start with the curve. Okay, our curve is having this equation and the value of the k is basically 2. So I'm having negative 2xy plus 2 equals to 0. And assume that this is the first equation. Then for the second equation, I will substitute y equals to px. P means 11, so 11x plus 3. And this is my second equation. To get the intersection point, I have to solve them simultaneously to get the answer. So what I do now is I try to substitute equation number 2 into equation number 1. If I substitute equation number 2 into equation number 1, this is basically what I have here. 2x and then the y, I will replace it by using 11x plus 3 plus 2 equals to 0. Let us continue to simplify it. I will be having negative 22x squared minus 6x plus 2 equals to 0. And from here, if you continue to simplify it, okay, then we can see that we actually get the quadratic equation in terms of x. To make it looks nicer, I will want to simplify it first. So I want to make it become positive 10. That means I divide every term by using negative 2. So divide negative 6 by negative 2, you're having a positive 3. Then 2 divided by negative 2, you're having a negative 1, which is equals to 0 for the whole equation here. And next, try out and see whether we're able to factorize it or not when you want to solve the quadratic equation. By right should be able to factorize, yeah. I'm having 5 and also 2 with 1 and 1. I want to have positive 3, so positive here, negative here. Okay, from here, very easily you can get the value for the x, which is 1 over 5. Another value of the x, it will be negative 1 over 2. Right, so we get the x coordinate for the intersection point, and now let us continue to figure out the value for the y. So how to get the y? For my suggestion, when you want to find the value for the y, right, please use the linear equation if possible. So I'm using the linear equation here, 11x plus 3. So 11x plus 3. Therefore, we are getting this, which is 26 over 5. And also for the x, substitute the value negative half into the linear equation. And by right, you'll be getting the value negative 5 over 2. Okay, so we successfully get the coordinate for the x and also the y here. We are having 2 points here. So for me, I would prefer to write out again the final answer. The intersection point, there are 2 here. So the first one is 1 over 5, then 26 over 5. The other one is negative half and also negative 5 over 2. Right, yeah, so this is how we solve the part A for question number 6. Let's proceed to part B. For part B, now they give us the value for P equals to 4. Find the value for K, the set of value for K, which the curve and the line do not intersect. When you're having a curve and also the line, right? If let's say I simply draw a curve here, let's say I'm having a curve and I'm having a line, when they do not intersect with each other, it is just like the case where the quadratic equation doesn't meet the x-axis. So because of this keyword, we have to use b squared minus 4ac smaller than 0 later, because of the word do not intersect. Okay, but before we can find out the value for, before we can use the equation for b squared minus 4ac smaller than 0, we have to substitute our equation into the other one, okay, into each other. That means you assume that you want to find the intersection point. Then you need to form a quadratic equation first before you can apply b squared minus 4ac smaller than 0. Okay, so let us start. For this question, they give us the value of p, which is equals to 4. Our curve equation, right? What is the curve equation that we have? Right, so according to what we have in the first part, the first equation of the curve is 2x squared minus k. Now you just assume that the k remain the k, right? You don't use the value of k in the previous example, in the previous question. This is my curve equation. And for my linear equation, I'm having 4. P equals to 4 now, so 4x plus 3. This is the second equation. Before we can apply b squared minus 4ac smaller than 0, we still need to substitute linear equation into the curve equation and assume like you want to solve it simultaneously, right? So substitute 2 into 1 again. What do I have here is I'm having 2x squared minus kx. The y, I replace it by using 4x plus 3. Then plus 2 equals to 0. Simplify this whole equation here. And I want to group all the x squared together. Therefore, my x squared, I'm having 2 minus 4k x squared, then minus 3kx plus 2 equals to 0. And now, once I successfully get a quadratic form equation, this is the time that where I want to apply the formula b squared minus 4ac smaller than 0, because of there's no intersection point. The curve and the line doesn't intersect with each other. So this is the result that we have to use. And you need to know again, what is the value for the a? Basically, this is the a, yeah? And then what's the b? B is the coefficient of the x. And what's the c? C is the constant term. Right? So let's start using this equation. B squared minus 4ac smaller than 0. B is negative 3k squared minus 4. A is 2 minus 4k. C is 2, then smaller than 0. Okay, then continue further. Negative 3k squared, you're having 9k squared. Then minus 8. 4 times 2 times 2, right? So negative 4 times 2 is 8. 8 times 2 is 16. You will be having negative 16. Then positive 32k smaller than 0. And again, you get another type of quadratic inequality here, and please solve the quadratic inequality by using the technique that you like. Okay, so for me, personally, I prefer to draw the number line. So I try to factorize it first. I'm having 9k with k. And after that, I'll be having 4 and also 4 here with a positive and also negative. Because I want to get positive 32, right? So 9 times 4 is positive 36, yeah. So this is how we factorize it. And from here, I get my critical value. My critical value for the k is 4 over 9 and also negative 4. So this critical value is the reference point for me to draw the number line. I'm having negative 4, I'm having 4 over 9. Okay, draw the number line, both bracket going to the right hand side, because my bracket is 9k minus 4 and also k plus 4, right? So both going to the right hand side. So you're having positive, negative, positive. This is plus, plus. This is negative, plus. This is negative, negative. Alright, so if you want to know more technique about the number line, how we draw the arrow and everything, please go and have a look for the lecture video in chapter 1 for AS, right? Okay. Then after you draw the number line, you have to decide the answer. We are looking for smaller than 0, right? That means we are looking for negative in overall. So we are having negative in overall for this part, which means that your value of k should be within negative 4 until 4 over 9. Please write out the answer again. So to get a inequality, the quadratic equation which is smaller than 0 for this particular part, your value of k must be between negative 4 until 4 over 9. So that the whole equation here, or the quadratic inequality here, the quadratic here will be the equation which is smaller than 0, which is the negative one, right? Yeah, so this is how we solve the question number 6. Question number 7, we are given an equation again of a curve, then this is what we have. A point P is moving along the curve in such a way that it is y coordinate is decreasing at 5 units per second. Okay, so from this sentence, when you see the word, okay, or maybe the phrase that mentioned 5 units per second, or maybe 5 cm per minute, it is over the time, right? Per minute per second. Basically, they are talking about the rate of change. When you're having anything with rate of change, when you want to write the symbol, it should be over the time. So you should be having a dt at the bottom. Alright? And for this question, we are talking about the y coordinate. Therefore, it means that the rate of change for the y, you will write out as dy dt. Okay? And decreasing at 5 units per second. Decreasing means that you have to put a negative sign. And then 5 units means negative 5. Alright, so from this particular phrase, you basically can get a very important information here, which is dy dt equals to negative 5. Right, then let's proceed further and see what the question wants. They want us to find the rate. Again, highlight the keyword rate. That means they want you to find something over dt lah. Okay, where the x coordinate for point P is changing when x equals to 2. They are asking for the rate of change for the x coordinate, which means that you have to find out dx over dt. But before you can find the dx over dt, right, you need some other thing to help you, where I need dx over something multiply with something over dt. And what is the something that I should use here? Then you refer back to the question again. In the question, because you can see that we actually get the value for dy over dt, which means that in this part now of the equation, I had to replace it by using the dy. So this part also need to have dy. Okay, so dy dt, I already successfully get the value from the question. And now, before you can calculate dx dt, we need to get dy dx first, or dx dy first. Okay, so this is what we need to do at the first step. So let us have this equation here, y equals to 4x squared plus 9x power negative 2 minus 8. So let's find out the dy dx first. Okay, so 8x minus 18, power you put in front, right? Multiply with the 9, you get negative 18. Then power minus 1 becomes negative 3. Then differentiate negative 8 is a constant, you'll get a 0. Right, so basically this is what you have for my dy dx here. Okay, and after that, I need to know how can I get the dx dy, because later I need to use the dx dy in my calculation. So to make the calculation easier, I try to simplify this one first. I will be having 8x minus 18 over x power 3. And I will prefer to combine them together so that I can make it become dx dy easier later. So I want to combine them together. I have the same denominator. So the 8x will become 8x power 4. Then minus 18. Alright. Okay, then now, seems like I have already get everything that I need. I have the dx dy. This is dy dx. Then you can just swap it upside down, become dx dy. I also have dy dt. Therefore, I can find out the dx dt now. Okay, so let's find out the dx dt. It is equals to dx dy multiply with dy dt. the dx dy. Dx dy is this one, but you have to make it upside down. Therefore, you're having x power 3 divided by 8x power 4, excuse me. I'm having 8x power 4 minus 18 here, then multiply with negative 5. And now I have to substitute some certain value for the x so that I can get the value for this particular part. So in the question they did mention already where x equals to 2. Substitute 2 inside here. Okay, then if you don't do any careless mistake, right, by right you will be having 8 divided by 110, then multiply with negative 5. And eventually you will get negative 4 over 11 after you simplify your answer. So this is the rate of change for the x coordinate. Okay, so if you want it to be more accurate, you can just tell them that it is negative 4 over 11 units per second. Right? Yeah, so this is how we solve the 7 part A. Then let's continue to part B for question number 7. They want us to find the coordinates of the stationary point of the curve and also determine the nature. Okay, highlight the keyword stationary point. To get stationary point, the concept that we are using is we let dy dx equals to 0. Then from there, we try to get the x coordinate when dy dx equals to 0. Then when you want to determine the nature, you need d square y dx square and see the value, is it greater than 0 or smaller than 0. If greater than 0, that means you are having a minimum point for that particular point that you try to figure it out, right? Okay, so let us start. So first of all, we have dy dx first. I rewrite my dy dx again from part A. In part A, my dy dx, what I get is 8x minus 18x power negative 3. And now let us find out d square y dx square first. Differentiate 8x, you get an 8. Differentiate this whole thing, negative 18, you have to multiply with the negative 3 because you pull the power in front. When you pull the power in front, by right, you will be having plus 54. Copy the x, power minus 1 become negative 4. Right, so first step, we know that both, to determine the nature of the point, we need d square y dx square. So at first, I try to find out the d square y dx square first. After that, I need to figure out what is the stationary point. Let's continue from here. We let dy dx equals to 0. I'll be having 8x minus 18 over x power 3 equals to 0. Let's try to solve it. We are having x power 4 equals to 18 over 8, which is 9 over 4. Then to get the x value, you have to take the fourth root, or you can take square root for 2 times, okay, for the number 9 over 4. Square root 9 over 4, you get 3 over 2. Then you have to take the square root again. It will become plus minus square root 3 over 2. Because when you take the square root by yourself, right, you need to include the plus and minus sign. Right? Yeah. Then from here, you know that you're having 2 stationary points. One of them is positive surd 3 over 2. Another one is negative surd 3 over 2. Okay? Right. And now let us continue and decide which is the maximum point and which one is the minimum point. Right, so let's continue, yeah? Okay, maybe I put it here. When x is equals to positive square root 3 over 2, what is the value of the y? Substitute the value of x into your y equation. So I'm having 4, then surd 3 over 2 square plus 9 over x square, right? So again, square root 3 over 2 square minus 8. Try to simplify a little bit by using the calculator, or maybe just some calculation in your mind. You'll be having a 4 as a value, right? So as the y coordinate, you're having the 4. So this is one of the stationary point. And if I want to know whether this stationary point is positive or is maximum or minimum, then I have to substitute the value of x into the d square y dx squared. We are having 8 plus 54. Okay, so maybe I write in this way, 8 plus 54 over x power 4. What's the value for x power 4 just now? You know that it is 9 over 4 here, right? So you will be having 9 over 4. Okay, when you try to simplify it, you have 32, which is a value that is positive or more than 0. When you're having something, the d square y dx square more than 0 at this particular point, it actually tells us also that this stationary point is a minimum point. Let's make a conclusion here. This particular point is a minimum point. Alright, then let's continue for the second point. What is our second point here? When x equals to negative 3 over 2. So when x equals to negative 3 over 2, so we are trying the same thing. Try to find out the value of the y first. Substitute the value of negative 3 over 2 into the equation of the y originally. Okay, you will realize that if you didn't do any careless mistake, right, the coordinate of the y is also a 4. Then next one, we try to figure it out by using the d square y dx square also to see whether we get a positive value, or sorry, minimum value or maximum value. So again, it is 54 over x power 4. So x power 4 again, just now you are still having 9 over 4 here. It is equal to 32, which is greater than 0 also. And you can see that we are having the same conclusion for both points here. So don't forget to rewrite your answer again. This particular stationary point is also a minimum point. Right, so please state out clearly your result for the stationary point and also the final conclusion, whether is it the maximum or minimum point here. Right, this is how we solve the question number 7. Question number 8. The circle with this equation intersect, okay, highlight the keyword intersect the line x equals to negative 2 at the point P and Q. Find the area of the triangle formed by the tangents to the circle at point P and point Q, and also the line x equals to negative 2. Alright, so this question give you 8 marks, right, which is quite a lot. Okay, maybe for the beginning part, we try to figure out what is the value for P and also Q first, because they said P and Q is actually the intersection point of the circle and also the line x equals to 2. Okay, so I think the first step is you try to figure out what is the point for P and Q first, and then only from there we roughly know how is the triangle look like. Okay, that we are interested to find the area. Okay, right, so let's start with the P and Q first. To solve for to get the intersection point, basically you have to solve the equation simultaneously. And this is my circle equation. My line equation is x equals to negative 2, which is very straightforward. So I will straight away substitute negative 2 into my equation here. Right, so x squared means negative 2 squared. Then y squared minus 6, negative 2 plus 10y minus 27 equals to 0. Okay, so try to simplify further. And you can see that basically we'll get the quadratic equation in terms of y. So 4 plus 12 is 16, minus 27, you have negative 11. It is a quadratic equation, right? And again, we try to simplify it, or maybe we try to solve it by factorizing. I'm having positive 11, then minus 1. The two value of y that I get is y equals to 1 and also y equals to negative 11. Okay, so which one you want to make it as p, which one you want to make it as q, it is up to you. So maybe I put p as negative 2 and 1. How I know that the x-coordinate is negative 2? Because we just now already substitute x equals negative 2 into the equation to solve it, right? Okay, which means that your intersection point between the circle and also the line x equals to 2, p is one of the intersection point, and then q is the other intersection point here. Also, sorry, I should put a negative 11. Okay, so basically, we did the first part. Okay, but of course, this is not the final answer yet. There's a long way to go. Okay, then now, because they are interested enough to find out the area of the triangle formed by the tangent to the circle at P and Q, and also the line x equals to 2. So, x equals negative 2. So before I continue here, I need to know how my circle look like and also what's the center for the circle. Because you might need to use it to get the tangent later, right? The equation of tangent later. So let's talk about the center of the circle. To get the center of the circle, we need to complete square for this equation so that we can get the standard form. Then only we can continue further from here. Alright, so to complete the square, I will show it here on the right hand side. Okay, for the circle, I try to rearrange. So I'm having x squared minus 6x. Then I have to plus something square minus something square. I start the completing square here already. I take negative 6 divided by 2 and I will get negative 3. So plus negative 3 square minus negative 3 square. This is for the x. Then for the y, I'm having y square plus y. Again, I must be having something plus something square minus something square. And what is the something here that I should put? I look at the 10 y. So I take the 10 divided by 2, which is a 5. Okay, then the last one is the constant term. So minus 27 equals to 0. Okay, then next step, I try to combine the first 3 terms here, become one big bracket, x minus 3 with a square outside. This is a process of completing square. I hope that you still remember it. Okay, then negative 3 square, you are having a negative 9. Same thing happens for the part of the y. For the first 3 terms here, you combine it, become a big bracket with a square outside. So first and the third term, right, become y plus 5, then with a square outside. Then minus 5 square is 25, minus 27 equals to 0. Okay, then if I further simplify it, I will have 61. If I didn't do careless mistake, so I should be having the 61 here. And from this part, you know that the center of the circle basically is 3 and also negative 5. Okay, right. And now we already know the center of the circle, and we are going to figure out how to find out the area of the triangle formed by the tangent to the circle at P and Q. So let us start. I will simply draw a circle here. Some students, they prefer to draw it out on the axis, on the proper axis. They will try to plot everything nicely, but for me, I don't think that it is needed. Okay, as long as you can see it roughly, then it is not too hard for you to get the answer and solve it. Alright, so I know this center. This center is basically 3 and negative 5. Okay, you might need to use it later. If let's say this is a 3 and negative 5, when I want to draw the line x equals to negative 2, right? X equals to negative 2, it should be somewhere here. It should be before. Okay, so this line is x equals to negative 2. Because the center is x equals to 3 and negative 5, right? So I assume that the negative 2 is somewhere here. Which also means that you are having the intersection point here. Okay, so you can label it now lah. Just now you label P as negative 2 and 1, Q is negative 2 and negative 11, right? So the lower point here will be the Q, the upper point here will be the P. And how can I draw the tangent of the curve at the point P and Q? This is how the tangent look like. It will go through and touch the point P and also touch the circle at one point, which is the point P. Same thing happen here. Your tangent at Q looks something like this. Okay, it will pass through the Q and also the circle at one point, which is the point Q only. Alright, and can you see the triangle that we are interested to figure out? So the triangle is basically this one. So this is the area that we are interested to figure it out later. Okay, so before we can start, let us have a look for some properties that is helpful for us to solve the question. I need to form the equation of tangent at point P and also at point Q. What can I do now is I have to use a property where from the center to the point of the tangent, it is 90 degree. To the tangent line, it is 90 degree to each other, right? Therefore, I can find out and form the equation of tangent first by using this concept. Alright. Okay, so I label the center as a C, yeah? So let's start. For the first part here, I want to find out the gradient of CP. Okay, so I rewrite again. My P is negative 2 and 1. Q is negative 2 and also negative 11. So to find the gradient for CP, you can take negative 5 minus 1 divided by 3 minus negative 2. And the gradient that you get should be negative 6 over 5. And then what's the gradient of the tangent line? Because we know that the gradient of the tangent and also the line of CP, they are perpendicular to each other. So the gradient of tangent multiplied with the gradient of CP should be equals to negative 1. So by using this property, you know that the gradient of tangent should be 5 over 6. Okay? After that, you can form the equation of tangent at point P. How to form the equation of tangent at point P? Okay, so it is y minus the passing point is the point P, yeah? So I have to use the point P. Y minus 1 equals to m x minus holding out xi, which is become positive 2. Simplify this equation. Eventually, you should be getting 5 over 6x, then plus 8 over 3. Okay, so again, we solve one part here, but it is not the final answer yet. And I need another equation of the gradient at the point Q. Okay, so let's continue from here. Alright, I want to get the gradient of C and Q. Okay, negative 5 minus negative 11 divided by 3 minus negative 2. And this one will give you the answer, which is 6 over 5. Okay, then after that, what is the gradient of the tangent at the point Q? So you know lah, gradient of CQ multiplied with gradient of tangent should be equal to negative 1 because they are perpendicular to each other. Therefore, the gradient for this one should be 5 over 6 negative. Alright, then continue. You can find out the equation of tangent Q. So it will be y minus negative 11, right? So it will become y plus 11 equals to negative 5 over 6. Then x minus negative 2, which is become a positive 2. Then simplify your equation. you'll be getting this negative 5 over 6x minus 38 over 3. Yeah, and let us have a look. Yeah, why do we need to find out the equation of tangent at point P and point Q? So the main idea is because I want to find out the intersection point here, so that it is easier for me to calculate the area of the triangle later. Okay, so let's continue further. I want to find out this intersection point between the tangent. Show it in this part. Okay, so I solve equation number 1 and equation number 2 together to get the intersection point. Okay, so I'm having 5 over 6x plus 8 over 3 equals to negative 5 over 6x minus 38 over 3. Okay, of course, we want to simplify the equation here. I'm having 10 over 6x equals to negative 46 over 3. If you didn't do careless mistake, yeah, it should be negative 46 over 3. And from here, you're able to get the coordinate of x, which is negative 46 over 5. Okay, all right, so once you get the x coordinate for this particular point, for the area of the triangle, there are a few ways that you can try it. So here I will show you two methods here. Okay, how to find out the area of the triangle. So the first method is, after I get the x coordinate, I also continue to get the y coordinate. Alright, so the y coordinate will be 5 over 6. Some students will ask, which equation should I substitute it in? No matter which equation you substitute in also can, because the intersection point actually fulfill both equations. So you can use any equation that you like. So I'm having 5 over 6 multiplied with negative 46 over 5. Okay, then plus 8 over 3. And the y coordinate is negative 5. Okay, and after that, if I want to find out the area of the triangle, right, I need the coordinate of the vertices, because triangle is a closed polygon. So I can use the coordinate of the vertices and arrange them to find out the area. So this method, I don't know whether did you learn it before or not. Okay, if no, then you can consider the next method that I show you later. Right, okay, so let's continue with the first method first. Okay, right. Maybe I can use other color. So method number 1 is this one. To get the area, I just need to rearrange my equation, my points, my vertices of the triangle, okay, in either the clockwise form or anti-clockwise form. So like as an example for me, I will take the point P as starting point. So I'm having negative 2 and 1. This is a coordinate for P, right? Then I rearrange it. The next point that I'm using is the intersection point, negative 46 over 5. And the y coordinate is negative 5. Then the point Q is negative 2 and also negative 11. Then I repeat again the point P. So the point P, if it is a starting point, then it should be the ending point as well. Okay. Then to calculate the area, there's a formula here where you try to add all the multiplication for this direction. So you're adding together for all the blue color arrow when you multiply them together. So as an example, the first set is negative 2 times negative 5. So you're having a 10. Then you plus negative 46 over 5 multiply with negative 11. So from here you get the value 506 over 5. Then the third set is this one, negative 2 and also the 1. You'll be having plus negative 2. Okay, then after that, after you complete one already, then the other direction is you need to minus all the multiplication for this direction. Okay, so you minus, yeah? So as an example, 1 multiplied with negative 46 over 5 is negative 1, right? So you have to take minus negative 46 over 5. Okay, then negative 5 multiplied with negative 2, you get a positive 10, but you have to minus the positive 10. Then negative 11 minus the multiply with negative 2, you have positive 22, but you have to minus 22 here. Okay, so after you complete the process, you'll be having this. Then simplify your answer by right, you'll be having 216 over 5 or 43.2. Okay, so this is method number 1. Okay, but I don't know whether you still remember how we actually apply this or not. If let's say you can't recall about this formula, then you can have another option where you try to solve it using the length and also the height and also the base of the triangle. Okay, so because we are looking for the triangle here, and for the circle that I draw, it is not really nice, but in short, you need to know that when you are having any line, okay, or any chord that is in the circle, basically when you draw a straight line from center to touch the line, it is actually a 90 degree. It is a perpendicular bisector. So same thing happen here. If you extend the line, right, you should know that it will also go through the center. Okay, maybe I try to redraw this again, yeah. All right, so that you can see clearer. So I try to move this triangle down here. Okay, method number 2. So for method number 2, I'm interested to find the triangle. This is the point P. This is the point Q. And this is the point, intersection point. Okay, for point P, I'm having the coordinate negative 2 and 1. For point Q is negative 2 and also negative 11. And then for this point, we are having the coordinate negative 46 over 5 and also the negative 5. Triangle, I need to have maybe half, use the base formula, the basic formula, half times base times height. Okay, I assume that this red color part is a base. So what's the length for the base here? Okay, you know that the y coordinate is 1 and then the other y coordinate is negative 11. So the distance from 1 to negative 11 should be 12. So I assume that the base is a 12. Okay, then after that I want to get the height. What's the height for the triangle? Which is this one. Okay, so the horizontal distance here, what is the horizontal distance here? So you are looking at the x coordinate, right? So you're having negative 46 over 5 until negative 2. So what's the distance from negative 46 over 5 until negative 2? So you take negative 2 minus negative 46 over 5. Correct? And you should be getting 36 over 5. 36 over 5. Okay, so just in case you want to know how we get the value, this one we actually take 1 minus negative 11. Then this one, we are taking negative 2 minus negative 46 over 5. Okay? Then, because we want to know the length and the height, the length of the horizontal length here, the triangle, the height. Okay, and also the length for the PQ. So we assume that this is the base and this is the height. Then if you try to simplify this answer, it is also equals to what we get just now, which is 216 over 5 or 43.2. This is the second method that you can try to use out if let's say you can't recall this particular method here, because we seldom use this method actually, right? So you can use the basic area formula for the triangle and get the area as well. Alright, yeah, so this is how we solve the question number 8. It is quite tedious, alright, and long, but if you try to make it into a smaller part, right, you can solve it slowly. Right, so we'll end this question here. Right, so we are now at question number 9. We are given a diagram, and it is a sector ABC of a circle, right? The sector of a circle ABC, and then with the center A and also the radius R. The angle BSC is alpha. So they are trying to explain to us what is given in the diagram. Alpha is from 0 until pi over 2, which is a acute angle. It is given that the area of the triangle ABC is 4, and also the area of the sector ABC is 8 alpha. Find the exact area of the shaded segment. Exact area. Please highlight this one. Okay, so for this question, basically it is about the circular measure, right? What are the formula that we are going to use it very often? In this question, we need to focus more on the area formula. Alright, so just recall a bit. What is the formula for the area of a sector? The area of a sector, it should be half r square theta. Okay, and then how about the area of a triangle? So the area of a triangle, if let's say the triangle is not a right angle triangle, then basically the formula can be half AB sine C. So you're having maybe the length for two sides, and then sine, the angle of the angle that is between the two lengths here, A and B. All right. So from here, I can see that this is what we need. We need the area for the sector. We also need the area of the triangle. Right, so if you refer back to the question here, now they said area of the triangle ABC is 4 cm square. So we are going to apply our formula here. Area of triangle is given as 4. And according to the formula that we have here, how should we write out? Area is half A times B. So one side of the length for the triangle in our diagram here is AB, which is the R. It is the radius of the circle. Then the other angle, the other length for the other side is this one, okay, where it is also the R. So I'm having half AB, then sine C. The angle that we have is the angle that is between the two lines, which is the alpha, and it is equals to 4. Okay, then if I try to simplify this equation, I will be having R squared sine alpha equals to 8. And I can't continue to solve it anymore, so I will just keep this as equation number 1. Right, after that, let's have a look for the more information given in the question. Area of the sector ABC is 8 alpha. This is another information given, right? So let us write out the equation. Area of sector is given equals to 8 alpha. What is the formula of the sector that you have for the area? So we are having half r squared theta. So let's continue, half r squared. So r means the radius in our question here is also the r, which is a square. And the theta is actually the angle here, right, which is the alpha. 8 alpha. When you're having this equation, you realize that you can cancel off the alpha, and you'll be able to get the value for the r later, right? So r squared is equals to 16, therefore r should be equals to plus minus 4. And we only accept the r equals to 4 because the length of anything, right, it should be a positive value. So we ignore the negative 4 here, right? Okay, we are having r equals to 4 now. Once you know the value for r equals to 4, I want to get the value for alpha. So how can I get the value for alpha? Please substitute it back into the equation number 1. Okay, so I substitute back into the equation number 1. And what do I have? I will be having r squared, which is 16, then alpha sine alpha equals to 8. Then continue further to simplify. Your sine alpha is equals to half. Alpha, you take sine inverse half. So by right, you should get 30 degrees. But in this question, we are putting our alpha in terms of radian. So 30 degree in radian, it means pi over 6, and our alpha is pi over 6. Okay, so I successfully found the value for r and also the alpha. So let's see what they want us to find. Find the exact area of the shaded segment. If you have a look for the shaded area here, it is a segment, right? So basically, we are taking the sector minus a triangle. Then you can get the segment. Okay? You need to know how to figure it out, right? How to get the area of the segment. So I use sector minus the triangle and get the segment. And usually when I want to solve it, I'll write it out in my solution. Okay, so let's continue further. To get the area of the segment, I'm taking sector, the area of the sector, minus the area of the triangle. What is the area of the sector? So area of the sector is given here. Area of the sector is 8 alpha. 8 alpha means that 8, substituting the value for alpha, which is pi over 6. What is the area for the triangle? It is also provided in the question where the area of the triangle is equals to 4. And I can substitute the 4 directly here. Then try to simplify your answer. You will be having this 4 pi over 3 minus 4. And this is the area of the segment that we have. And please keep your answer in the pi form because they're asking for the exact area. Exact area means that you cannot keep your answer into decimal number. Right, so you have to keep it just in terms of pi and also the number. Okay, this is how we solve the part A for question number 9. Then let's continue to part B. Okay, so for part B, now they are saying that it is given instead that the length of the chord BC is 1 over sub2 RCM, but the area of the triangle still 4 cm squared. Find the area of the shaded segment, then give your answer correct to 3 significant figures. Okay, so if we have a look for the diagram again, yeah, now they are saying that, okay, for the A, B, and C that I have here, I simply draw, okay, so this is A, then I'm having the B. What's the B again? Let me go back to the diagram. Okay, B is this one, C is on top, right? Okay, so I'm having A, B, and C, and now they tell us that this is still the R, this is still the R, this is the alpha, but now we are having the length for BC. The chord BC means 1 over sub2 R. Okay, and now they want us to find the area of the shaded segment again. To find the area of the shaded segment, of course, we need to try and figure out what's the value for the alpha and what's the value for the R. Okay, by looking at this triangle, I can actually form one equation by using the cosine rule. I don't know whether you still remember the cosine rule or not. Okay, so just recall back, yeah, cosine rule. When you're having the triangle with the side A, B, and C, right? And also the opposite angle as A, B, and C, capital letter. So cosine rule should be something like this. If let's say you're having C square, it can be written as A square plus B square minus 2AB sines, cos C, sorry. Same thing happen here if you make the A as the main object here. So A square can be written as B square plus C square minus 2BC cos A. Okay, where the A is the opposite angle of the length of A. Alright. Okay, so we are trying to use this cosine rule and apply in our triangle here so that we can form one equation from this part. Let us start. I want to, because I have alpha, okay, my angle alpha, so the main object that I want to take it on the left hand side here will be this one, BC. So I'm using the formula where BC square equals to AC square plus AB square minus 2 AC AB, then cos theta. Cos theta means cos AC, cos alpha, right? Okay, so what's the length for BC? My length for BC will be R over sub2 square. AC is R square, AB is also R square, AB square is R square minus 2 AB, then cos alpha. Try to simplify, I'm having 1 over 2 R square plus equals to 2 R square minus 2 R square cos alpha. Okay, then continue to simplify it and see what do we get from here. Okay, I'm having 2r squared cos alpha can be written as 2r squared minus half r squared. Simplify the term on the left hand side. You'll get 3 over 2r squared. Further simplify it, you have cos alpha equals to 3r squared over 2 divided by 2r squared. Then if you try to simplify from here, you have cos alpha equals to 3 over 4. And of course, if you want to continue and solve for the alpha, you're able to get it right, because if you take cos inverse 3 over 4, then you'll get the value for alpha. But for now, I don't think that I need to find the value for alpha first. I just keep it in this way first, right? Okay, so let's continue further. I know the value for alpha. And now, how can I get the value for the r? I need another equation to start with. So let's have a look for the question one more time. Now they say that the triangle of ABC is still the 4. So please use this information to continue. Alright, so the area of the triangle is equals to 4 still, right? Okay, general formula is half AB sine C. So it is still half R times R and then sine C, so sine alpha. And it is equals to 4. Can I get the value for R? Yes, because you already get the value for alpha just now, right? Just I didn't purposely go and figure it out. Right, then you have to go back to our result just now. Okay, so for this one, if I know that cos alpha is actually 3 over 4, if I try to draw it by using a diagram, right? If let's say this is the angle alpha, 3 will be the adjacent length, 4 will be the hypotenuse. So what happened to the opposite length here? So you are taking 4 square minus 3 square, right? Then you take the square root, 4 square minus 3 square, and you take the square root. By right, you will be getting square root 7. This is the triangle that I can get from the result of cos alpha that I get just now. And now I want to apply this result into my calculation in the next part. I'm having half r square, so r square you just copy. Sine alpha, what's the value for sine alpha? Here it should be square root of 7 over 4. Opposite over hypotenuse, right? And it is equals to 4. Okay, so please solve it continuously. Okay, continue and solve it. By right, you'll be having r square is equals to 32 over square root of 7. Then if you want to get the value for the r, then you have to continue and take square root again for this particular value. But for me, I don't want to continue and get the value. I will just keep it like this first, because this is not my final answer yet, right? So what I want to do now is, I want to get the area of the shaded segment. So let's continue. Area of the shaded segment. Okay, can I just put it here? Area of the shaded segment. Like what I told you just now, we try to figure out what is the general formula first. To get the area of the segment, you need to take the area of sector minus the triangle again, right? Okay. What is the formula for the area of sector? It will be half r squared then alpha. Then minus the area of the triangle, which is a 4, because it is here as a 4, right? They already tell us just now. Okay, let's substitute in the value here. I'm having half r squared. So for r squared, I directly substitute this value, 32 over 7. Then how to get the alpha now? To get the alpha, there's no other choice. You have to take cos inverse. So cos inverse 3 over 4. And after that, you minus the 4. Okay, so from here, by right, you'll be getting 0.370, a long value. Okay, then of course, I want to cut it short into the 3 significant figure as a final answer. So by right, you should be having 0.371, which is a 3 significant figure answer. And I will keep this as a final answer here. Right, yeah, so this is how we solve the question number 9. Question number 10, which is the last question for this paper, right? Okay, we are given function f and g, and then this is what we have. Describe fully a sequence of transformation where we are trying to map fx to the graph of gx, you should make clear the order in which the transformations are applied. All right, so let's have a look for my function fx. Yeah? The function f is actually square root x, and then we want to change it to become this function g. Okay, so from what we can see here, we can do it slowly here. Okay, so as an example, we start from square root x first. When I'm having the square root x, the next step that I want to get is the square root x plus 2. We try to settle everything inside the bracket first, inside the basic function first. So in this case, my basic function is actually square root x. Yeah? Okay, so I want to put a plus 2 inside the basic function. And when you're having a plus 2 inside the basic function, that means that this is actually f x plus 2. So how can you write out the fx plus 2? When you want to write out in the statement, okay, so by right, this is a translation in the x direction, right? So we usually write it as translation with the vector of -2 and also 0. Okay, so this is what we did for the first step. And then after that, for the 3 and also -5, both of them appear outside the basic function square root. So according to the normal type of operation that we learned before, right, mathematical operation, we should multiply first, followed by minus. So multiply and divide first. So we are having a multiply with 3. Next step, we are going to put it in this way, where I want to multiply a 3 to the function that I have. When I try to multiply the 3, it is like you are multiplying a 3 outside the basic function. And how can we explain this one, or how can we describe this in a statement form? So the next transformation will be, it is a stretch. Stretch in the y direction, or parallel with the y-axis also can, yeah? You have to tell them what is the direction here. It's a vertical stretch. Okay, what is the stretch factor for this one? So you will be having the stretch factor of 3. Okay, and after that, the next one will be, I need to put a -5 outside my whole function here. Okay, so if I continue further, I will be having 3 square root x plus 2, then minus the 5. So minus 5 is outside the basic function, so it is something like this, 3f x plus 2 minus the 5 outside. And it is again a translation, but it is a translation in the y direction. What can you do is like translation with the vector of 0 and -5. Okay, so from here, if I show you the answer step by step like this, basically you can see that there are 3 transformations here. The first one is the translation. The second one is a stretch in the y direction. The third one is still a translation, but it is also in the y direction. Okay, there are some other way for you to express your answer. Okay, so some students will say that, can I try to combine the translation in x and also translation in y together? Okay, because translation in x and y, one is in x direction, another one is in y direction, right? So no matter which one comes first, it doesn't matter one. But our problem is, we are having stretch in the y. This is the stretch in the y, and this is also the stretch in the y. Okay, when you're having both transformation that is in the y direction one, then you have to be very careful. We need to know which one must come first. And like what I told you just now, according to what I show you, I multiply first usually, then only I follow by minus, right? So in this case, your answer, the stretch in the y direction must be coming first before the translation in y. So you have another option basically. If you want to rewrite your answer again, you can make it in this way, where the first transformation is stretch in the y direction with a stretch factor 3. Then after that, only you combine the both translation together. So you can say that having the translation with the vector of -2 and also -5. So in this case, if you combine x and y together in the translation, then this is what your final answer look like, how your final answer look like. Okay, Right? If you want to combine, then you can combine it in this way. You cannot put a translation before the stretch. It is because of, according to what we learned before, stretch in Y and also the translation in Y, the stretch must come in first. Okay, because you multiply the number first, only you minus a number at the back. Alright, so there are the two options here. One is like this, another set of answer will be like this. Okay, so this is the transformation that we can have. Alright, okay, then let's continue further for part number B. Now they show us a diagram again, and then they say, oh, this is the graph of gx. They want us to sketch the diagram of g inverse x together with any relevant mirror line. Okay, so for information, for inverse function and the original function, right, they reflect each other at y equals to x. So the y equals to x will be the mirror line. And usually we will try to draw a mirror line, y equals to x. So y equals to x is this one, pass through the origin, x equals to 1, y equals to 1, x equals to 2, y equals to 2. So you try to draw it by using a ruler. This is a straight line, and don't forget to label it x equals to y equals to x. And this function, of course, is the gx. To sketch g inverse, what you need to do is like you need to reflect it. So usually I will tell students, if let's say you don't really sure how to reflect it, right, you just swap the x and y coordinate. So as an example, this is your x, right, originally, and you try to measure what's the length here. Okay, if let's say the length is 1 cm, let's say, then you just convert it into the y. So that means for the y value here, I'm having a 1 cm here. So you plot the point. Then after that, for the y, this one, you try to measure, how long is this one? Okay, so let's say it's 1.5 cm. So you convert it into the x, where at the x part, you try to make it into 1.5 cm as well. Okay, so you can see that the green color part originally is x, right? I reflect it to the y. And then for the purple color part here, the point here, I reflect to the x-axis. So y become x, x become y. And after that, you try to imagine that this is a mirror, right? You can maybe fold it a little bit, okay, or whatsoever. You try to imagine that this is a mirror. If you reflect the line over, by right, your line should look something like this. My I cannot draw it very nicely, because I'm using the pen here. Okay, then for you, if can, you try to draw it as nice as possible. Okay, then this will be your g inverse x. My drawing is not so nice, but you try to imagine this is a mirror, and then when you fold the graph over, this is how your graph will look like. So don't forget to label your graph again, which is g inverse x. Then let's continue to the next part, part number C. They want us to find the expression for g inverse x. So let me show you what is the original function first. Original function gx is basically 3, then square root x plus 2 minus 5. So I'm having, this is the gx. So I let y equals to something something x. To find out the inverse function, I make it become x equals to something something y. Okay, so I try to move everything over. So I'm having y plus 5 equals to 3, then square root of x plus 2. Then after that, I move the 3 over. I will be having y plus 5 divided by 3. Then I try to square it. I'll be having 1 over 9. 3 squared is a 9, right? So y plus 5 squared. Eventually, I try to minus it. So minus the 2. So minus the 2, I will be having 1 over 9. Then y plus 5 squared minus 2. And this, you can see that I successfully changed the equation x equals to something something y here. And which means that this is already my final answer for the inverse function. So I'm having 1 over 9, then x plus 5 square minus 2. Okay, so not too complicated this one, right? Okay, then let's discuss further for part number D. Now they ask you state the range of the inverse function. Can we know what is the range of the inverse function? You have to try to imagine again about an important rule in the inverse and also the original function. When we map x to y, right, this is the function g, and if we make it opposite way, it is the g inverse. If you look at the function g, the first set of value here is the domain of the g. And then if we have a look for the second set, it is the range of the G. But this second step is basically the starting point, the starting value of the G inverse, right? It is also the domain of the G inverse. And this one basically will be the range of the G inverse. So from here, you know that the two important results that you can see. Domain of G should be equal to the range of G inverse. And also the range of G should be equal to the domain of the G inverse. Right, and now for this question, they ask us state the range of G inverse. So we know that the range of the G inverse is equal to the domain of the G. So very easy, you just need to refer back to your function G. What is the domain for function G? X greater equals to -2. So in our answer here, to write out the range of the G inverse, it is also greater equals to -2. But because we are talking about the range, right, it should be the value for y, so it should change, it become y greater equals to -2. So this result, I think you need to remember it because it will be asked, I think, quite frequently, right? Then let's continue further. For function, for part E, now we are given a function h, where hx equals to x minus 2. Okay, find the value of G inverse h4. So we need to substitute in the value. So first, let us substitute 4 into the function h first. So I will be having G inverse. Substitute 4 into the function h, that means you're having 4 minus 2. And now you're having G inverse 2. And now substitute the 2 into our G inverse function, which is this one. 1 over 9. Then 2 plus 5 power 2, then minus a 2. Okay, you try to simplify this particular part here, you'll be having 31 over 9. It's also a simple question, right? Okay, so lastly, for part number F, which is the very last part for this whole paper, explain why the composite function H inverse G cannot be formed. Highlight the keyword composite function for H inverse G. HG inverse. Right, again, to answer this question, right, you have to recall back about the domain and range again for the composite function. For composite function, basically it means that we are having two functions here, right? Okay, we are sending x become the y in two function. So sending x to one set of value by using the G inverse first. Composite function means you start from G inverse first, right? Then followed by the h. So followed by the h. Okay, the first circle here, you can see that this is where the G inverse starts. Therefore, we can label it as the domain of G inverse. This is the end of the G inverse function, so we can write as the range of the G inverse. Same thing happened here. For this particular set, you can see that it is a starting part of the function h. So I can write as the domain of h. And this last circle here, the last set here, will be the range of the function h. So from this arrow diagram, you can see an important result as well, where the range of inverse function should be equal to the domain of the function here. The range of the inverse function g should be equal to the domain of the h. Okay, so range of the inverse function g. What do we have? We are having it as y greater equals to -2. Domain of the function h is given in the question just now, which is x greater equals to 0. Okay, so you can see that are they the same? They are not the same, right? Because you're having some extra value for the range of the G inverse. They are not exactly the same. So you can say that the R, the range of the inverse function G, is not within the domain of the H. So that's the reason why the composite function cannot be formed. Because to make sure that you want to form the composite function, right, this particular result is important. You need to have the range of G inverse equals to the domain of the H, right? Yeah, so this is how you explain it. But in exam, I think you need to show the diagram. This diagram is mainly for understanding purpose, right? Okay, thank you very much for watching the video. This is the end of the whole paper. If you feel that the videos are useful for you, please ask your friend or maybe help me to share out the channel and subscribe. Thank you very much.